we will get started. My name is Dorothy again. I work at Sentry on the marketing team. And again, just really excited to share with everyone today and have you guys join us to chat with the Unity team on cheat codes for game development with Sentry and Unity. In terms of what you can expect out of today, we will go through a quick round of introductions and welcome for everyone. And then we've got Joona from the Unity team here. We'll go through introductions in a second, but he'll chat through what Unity is and how that relates to Sentry and how we're partnering together. And then we've got some folks from the Sentry team as well that will introduce Sentry in case you're not familiar. If you're new to the Unity SDK, we'll run through all of that and then give you a really strong demo as well. And then we'll end with a fireside chat as well as some questions. So just a few housekeeping things on this as well. Everything is recorded, so you will be able to get the recording after this. We will share it within about 24 hours or so. So if you want to take notes, you totally can, but we will be sharing this recording out after. And then there is the chat and the Q&A, so feel free to use that to make comments or ask questions or things like that. We'll try to save some time at the end to answer some questions live, and we'll obviously be trying to answer our best throughout the call as well. And then there is a quick survey. It takes like two seconds maybe to answer them at the end. If you are able to help us give some feedback at the end, these workshops are for you. We really try to take everyone's feedback into consideration when we plan for these throughout the year. So please do me a favor and fill those out, and I will greatly appreciate it. All right, I will go through a quick round of introductions. We'll actually start with Stefan, our Unity SDK engineer at Sentry. Do you want to introduce yourself, Stefan?
Yes, hi, my name is Stefan Jandl. I'm working as an SDK engineer for the Unity SDK, and I joined Sentry early last year.
Awesome. Thanks, Stefan. Bruno, you're next.
Cool. So my name is Bruno. I work for Sentry for almost 4 years now, most recently as an engineering manager, but I've been building SDKs for the whole 4 years, including Unity. The first support Sentry added was about 2018, but since then, a lot has improved and there's a lot more support. And all the SDKs that I worked are .NET and Android, iOS, Java, and mostly all the mobile SDKs.
Awesome. And then last but not least, Joona.
Hi, everyone. My name is Joona Rahko, and I work as a principal engineer at Unity. Been at the company close to 5 years. For those of you who don't know, Unity is one of the world's largest gaming engines. In 2020, we served around 2.5 billion unique devices, and roughly 5 billion apps made with Unity were also installed. Beyond game creation, Unity also offers a variety of game services that help game developers to better operate their products. Things such as analytics, monetization, matchmaking, and so forth. Beyond games, Unity also has product offering other verticals such as film and industrial. My personal connection point to Sentry is that we use it to monitor some of our web services and offer customers crash-free experiences. And a warm welcome from me for everybody as well.
Awesome. We are very excited to hear from each of you today. We'll do here as a moderator. We'll also be helping to moderate the chat as well. He leads our PMM team. I don't know if you want to also quickly introduce yourself, Rahul, before we dive into Joona.
Hey everyone, thanks for joining. Like Dorothy said, I work in product marketing. I've been at Sentry for a couple of years now, but I'm looking forward to today's session. We got a great panel for you. Thank you.
Awesome. Thank you, everyone. Joona, I will let you take it away. I'll stop sharing. All right. Joona, it is all you.
Me?
Yeah.
I think we're handing it off to Stefan.
Oh, sorry, Stefan. Sorry, that was my bad.
Stefan. Yeah,
my bad.
Yeah, it's Stefan. Exactly.
Sorry.
Yeah, no problem.
We are live.
So let me share my screen then. Before that, I don't think making games has ever been easier than it is right now. even though you have those vast domains you have to cover, from visuals to sound, networking, physics, like where do you even start? And that's what makes Unity so great, because everything you might want to need at some point, it's already there, and you just have to actually create your game. There's a second part about game development that comes after you've released your game out into the wild, and is you want to support it. It might end up on a lot of different devices in a lot of different configurations. And how do you know that everything is working as intended? You could rely on user feedback and traditional testing, but I don't think that's enough. Not every user gives feedback, and not every user even gets the option to report a bug. And there's a lot of context information that user developer definitely want to have, like what happened before that, and when did it happen, on which device did it happen, what did you actually do, and maybe even line numbers, like on which line in your code did your game actually break. So this is where Sentry comes in, Unity is one of the most, if not the most, popular game engine. And we here at Sentry wanted to improve the coverage for Unity developers. So we started adding features to the already existing .NET SDK, like Android and iOS native crash reporting. But the thing when developing tools is it's best practice to actually use it yourself, so you can effectively test it. The problem was we are developing a tool for game developers, but we don't have a game. So last summer, during our annual Hack Week, we got together, and a couple of us, we built a tiny little tower defense game called Sentry Defenses, so we could properly dog food our own SDK. So now let me share my screen. Let's hope there's no, does that work? So we're here in the editor, and this is our little tower defense game. So if we hit play, we have a start screen, click battle with a little animation. We can build new sentries, we place towers. Maybe we place a second tower.
And there's like
battle.
One thing to add, like these monster, the locations they come, it's actually based on geolocation of real events that come into Sentry. So we call a web service and get the, based on the country where it comes from, we create a coordinate. Anyway, there's a whole Hack Week project about this. Sorry, Stefan.
What I prepared for us, because okay, we have the game now. Where's Sentry? So I prepared a little button, buggy button, and if I click that button, there's some faulty code in the background that's going to create an error. So I click that button, I log a little message, I click the buggy button, and there is my error. So if I now go to Sentry.io, I'm here on the issues page for our dogfooding game. Give it a quick refresh. And there I already have the exception. It has the same message as the one on the console inside the editor. And if I open that one up, I get all the additional information about that issue. It starts at the top with tags. Those are very helpful, like for example, the operating system and which version of that operating system. We have which device it happened on. The installation mode, we can see it happened on an editor. Those tags you can add your own. A bit further down, there's information about the exception itself. We can open up the full stack trace so we can see a bit more what's going on and peek a bit inside the Unity engine. So there was some event update, something got clicked, a button got pressed, there were events evoked, and then we had our on buggy button click. After that, we have the breadcrumbs, and the breadcrumbs are basically how you can track what happened before your issue occurred. So it starts all the way at the top. There was scene loading going on, game start. Bruno mentioned that we fetched the bugs. So there's that web request. Some additional logs about animation finishing. There's some transitioning about the game state. And at the end, the log message that happened when we click the button gets automatically picked up as a breadcrumb and added to the event together with the exception. Here at the bottom, there is additional information about the device, battery status, what kind of device, about the GPU, some operating system information, some Unity specific things like installation mode. So the question, how do you get that? Like, what do you need to do to integrate Sentry into your own project? So for that, let's head to Google, Sentry Unity. That should take you straight to our documentation, where we provided you, we will provide you with a link. So you copy that Git URL, you head back into the editor. Let's pause it for a second. And under Window, Package Manager, you have that little plus icon on the top left, where it allows you to add a package from a Git URL. So you click that, you paste the link in there, and you add it. Sentry has already been added to that project because we use Sentry. We have that project doc for Sentry. And what you have now is under Tools Sentry, you have access to the Sentry configuration window. The only difference between the configuration window you see here and if you do it yourself for the first time is that the DSN, we already provided ours. Our documentation will help you where you can pick up yours. You paste your DSN in there and you're good to go. Like all the functionality that I've shown off so far works out of the box just by providing that DSN. What I didn't show you so far is, I mentioned before that we added iOS and Android native crash reporting. So how would that look? The package manager, you can see here, we provide some samples with our Unity package. And we added those samples as an Easter egg in our own game. So if we click that text at the top, it loads up the sample scenes. Let's go to mobile native support. And if we were to throw, like it doesn't work on the editor because it's a native plugin. Let's say your game uses some C++ code and you compiled it with IL2CPP and it crashes in that native plugin. So if you could click that button that emulates that crash. And inside of the Sentry dashboard, I already picked it out, is that crash in C++. You get to see the same tags. You get to see the stack trace. You can see it's crash in CPP inside a C++ file. The breadcrumbs are provided. And another feature that you have access to just by adding the DSN are alerts. So you get to pick some conditions that match your need when you want to be notified about some issues. Like you can have issues themselves, number of issues. You can tie it together with crashes. And lastly, we have release health.
Yeah, and I just want to say, like, one thing worth noting, you have some alerts out of the box. Basically, if you create a new project in Sentry and a new issue is created, you already get an email. You can configure this. For example, you can get a Slack message or Microsoft Teams message or a bunch of different notifications. And it's interesting that you don't get an email on each error that happens on the game. You'll get it on each new issue because the same error, multiple instances of it are grouped together in a single issue. So this helps with you not being spammed, right? And it's a huge difference when people want to understand the difference between Sentry and a logging tool where you're just dumping a bunch of log errors, right? Sentry has all these grouping based on algorithm.
Oh, that reminds me that's what I forgot to mention before was like this is another bug where there's a null reference that got triggered from within the sample scenes, and we tested it out on a bunch of different devices. And here on the right, you get to see statistics about the the different
Device
tags.
model. Yeah.
So you get to see it happened on a Samsung device, and it happened on a OnePlus, and there's an iPhone there, and there's an iPad. You get to see in which environment it happened, even operating system. So we have a lot of Android devices we tested it on, and just a little bit of iOS devices. It's interesting to see in which releases it happened. So it bundles those issues together and gives you some more information about those.
Yeah, that's nice. And so this tag distribution can help you if you have a really like a high load app, lots of errors in it. You often see that it's distributed across multiple operating systems and versions, but sometimes you see this only happens on iOS or only happens on Android or only on Windows. So it helps you narrow down already a repro to start with. And one thing Sentry can tell you is like in which release was the first release where this issue happened. So you already know like what changes to look for, right? And it brings us to this releases page. So here you can see release adoption. That's the first view. Basically, will tell you can have more than one release. Say you release a new version on the store, but before everybody had downloaded and updated, you have more than one release in parallel. So it supports this adoption, right? Like in what release are most of your users at this time? It will tell you the crash-free rate. So how many of user sessions have no crashes? So if you open, say, like 105, we can see how many sessions had errors as well through, there's crash-free rate, the crash-free users, because the SDK reports a different user per each like device installation. This is like anonymous. It's not about the user itself. It's just a random GUID created when the app is installed. But it's able to give you statistics that help you to understand each release you make of your app. Is it getting more stable or less stable, right? And when a new issue comes, if you scroll down, you can see new issues. So when I made a new release of my app, what new bugs were introduced, right? So all of this helps you focus on the most impactful work. You can see this issue affected 2 users, the other one only 1 user. So you can spend your time and focus on the issues that are more impactful to your users. So we can see here on the last one, we have transactions as well. So Sentry, besides crash reporting or error monitoring, which how it started, also has a performance product we've been working on. We did instrument our sample game, the Sentry Defenses game, with performance monitoring. You can see like Stefan is navigating through. So when we make this HTTP request to the backend, it creates a span that represents this connection on the backend, and then we instrument the backend as well, and it connects end to end. But so this is a manual instrumentation. So we use our API. You can see on the code is open source. Everything Sentry does is open source. You can see how we instrumented it, but we plan on adding this out of the box as well. So you don't need to do anything else, and you already measure the performance of your game. So it's something we plan to do it still, this year, basically. Yeah. I think from, their user feedback is another feature that you can use programmatically. The SDK has an API. It's something we want to add a prefab inside the SDK. So you can just drag and drop, and you have a little nice model to ask the user to add any additional explanation of what they were doing, what was going on, or any sort of feedback. Yeah, but I think this sums up, a quick demo of our little tower defense game and how we use Sentry to test our own SDK.
So how do I stop sharing?
Sure.
Thanks for that demo, Bruno and Stefan. Joona, do you have any thoughts on what we just showed and what we've been working on for the past few months?
No, it's great to see like make Mid-Sentry available to Unity users, and the more tools our developers have to use, then the better, right? But looks cool.
Thanks. It's a good transition. It leads me to like, while I got you, and I want to pick your brain on a few things about just the industry in general, like gaming industry in general. Like,
yeah,
in your opinion, why do you think it's important to have some kind of real-time telemetry on your game, especially if you're a game developer? Why is this type of technology important to you?
Yeah, that's a good question. Like offering like crash-free experiences to users is the right thing to do by them, obviously, for sure. but it's the right thing to do by your business as well. Like imagine your players are making some good progress in their game and are about to hit that next save point and the game crashes. That would be very bad for the user experience. And our data also shows that in many situations like this, the players are very likely to abandon the game and uninstall. So if you're trying to get players to your game, that's not a very healthy way to go about your business. Traditional manual QA obviously helps to make sure that some of these very obvious bugs don't make it into production. But just because the sheer number of devices and different conditions that your game can be running in, bugs will always slip in, and having automatic monitoring in place will help to make sure that your game is of high quality. Furthermore, you don't want to rely on your customer reports to fix bugs, because that creates a long lead time into getting those bugs addressed. And in many cases, customers will not report the bug to you. They will just uninstall the game and never come back, right? So having that automated monitoring in place helps them both reduce the lead time and also catch more of the bugs that will be impacting your game. And most importantly, if you're building a game and you have hopes of monetizing it and making some money out of it, crashes will have a direct impact on your retention metrics as well as your monetization metrics. So it will have an impact on your bottom line as well. So for those reasons, it's very important to make sure that you have as little crashes in your game as possible, and you have real-time monitoring in place.
Oh, that's really interesting. You bring up a point about retention, which I've always been wondering, like, what's like the difference between working on a game and like a productivity app or a non-game based app. For example, like if I'm using something for work and I experience the bug or crash, I just swipe up, close the app and reopen it. But it seems like what you're saying is game developers have an entirely different experience. And their users, if they experience something, they just can't swipe and start all over again. So like, what do you think how's it different building a productivity app or a run-of-the-mill application that's not a game?
Well, before going into differences, I think like there's a lot of similarity these days in game development, product development as well. I think like game development has moved more towards product development, where games are not just only built, but they're being operated. So things like monetization, crash reporting, analytics is very important at the core of your operating your product. But how these things are different, there's very, very key differences too, is that games are often linear in their nature. So if you think about a platformer, for example, a racing game or some kind of strategy games where you have levels and whatnot, if you have a game crashing in a specific point in your game, you can actually prevent the players from progressing at all. And in many cases, people would uninstall the game very soon after. And that would be very detrimental to your game. If you think about like regular SaaS applications, like a dashboard or something like that, it is far more likely that a piece of your application might not be working at a given point in time, which is most likely less detrimental to the user experience because they're not completely plugged, right? So I think the linear versus kind of non-linear user flows are some of the differences between the two.
Yeah, so what you're saying is like a normal productivity app, there's if the direct happy path isn't working, there's obviously there's a good chance there's a viable workaround. But in game development, it's like you can't advance that level, like you're pretty much done. Yeah. So that adds like a series of challenges as a game developer.
Yeah.
Unless we get some cheat codes, right? I think some folks
are
looking for the cheat codes.
Yeah. Obviously not to say that you can't have blocking paths in like regular applications, but they're just more likely in game development because there is usually a concept of progress and going from A to B.
I guess the other big challenge that I started thinking about for game developers is you have to have an experience that is seamless and consistent across like unified experiences, from consoles to tablets to phones to PCs. Like what are some of the challenges you've experienced like building software for experiences across multiple devices? Yeah. What are some advice you can give to some of our listeners today?
Yeah, I mean, like I'm not a game developer, so I can't talk to all the complexity that comes with game development, but I know that there's a lot of similarities to web development. So just the sheer number of devices and operating systems and viewports and browser versions, like all of those have an impact on how your application will work in the end, right? And managing that complexity is very hard. In web development, obviously, we've gone from a world that was far worse, where there was no alignment across the browsers and how API should be designed and whatnot, into a world where it is more or less aligned, but these problems still exist today, right? like in certain cases, your application might crash due to CPU or memory constraints. It might sound funny, like obviously, like in many cases, like not dashboardy applications usually run into those types of problems. But when we're moving like towards Web3 and so forth, like web-based applications are becoming more and more rich and more CPU and memory intensive, and these types of problems can happen. A common occurrence of a problem is like some browser APIs are being introduced, you rely on those and they're not available in another browser, and then your applications ends up crashing. To fix those types of things, like obviously having monitoring in place and knowing exactly like what browser is crashing and why is very important. So having that monitoring in place is the best way to make sure that you are able to manage the complexity that comes with all these different conditions that your application or game might be running in. There's other things too, like for Unity, for example, like we made managing some of that complexity easier by offering game developers a way to build the game once and targeting multiple different platforms. If you were to try to build a game and target Xbox and all these different things with your own engine, that would be far more harder. Because much like with browsers, these different platforms will have different memory constraints and they would have different APIs available and whatnot as well, right? So yeah, it's very hard, but having monitoring and so forth in place really helps to make sure that your application is high quality.
I just want to add one thing real quick. So one of the reasons why the native support that Stefan mentioned is important that we added. Sometimes you might bring in a Unity plugin that you get from the UPM package, and that package will give you a functionality, and you're calling it via C#, for example, something for payment or whatever, some sort of like a Google SDK. But under the hood, that will call in some native APIs, and it could be some Java package or Kotlin package that you have on Android, or something written in Swift or Objective-C, for example, on iOS. And without this native layer that we've added to the Unity SDK recently, these errors would go unnoticed, because even though you're calling to C#, it's crashing in a native layer. And if there's a Java exception, say on a background thread, that would not be end up a Unity logger, and it would not go on some traditional error crash reporting tools. So even though you might not know that you're calling some native code that would fail only on one platform, but it will be there on your game at the end of the day, right?
So Stefan, you're a game developer. Obviously, we saw from Sentry Defenses. What are some of the challenges you faced in building, at least in this case, a mobile application?
So before joining Sentry, I was working on augmented reality apps for mobile. And then we had that wide range of devices, a difference in performance that was available to us, and to custom tailor the content that we would provide to make it work from the lowest possible and supported device to the highest and newest beast of a mobile device was quite the challenge. Unity gives you a lot of options where you can tweak stuff. Like if you want to use techniques like atlasing your textures for your models, or if you want to even just profiling, like what's your bottleneck? Is it RAM? Do you have too little? Are you using too much? Is the CPU your bottleneck? Do you have to reduce draw calls? So Unity has been a very great working with Unity has been a very great experience so far.
Nice. Now I know we've got a lot of questions from the audience, so I will hand this back to Dorothy. And I know Stefan, Bruno, we still need to pick your brain on a few more things. So thank you for being with us today. Let's see what the audience had to ask for.
Awesome. And yes, we will definitely be picking all of your guys' brains today with lots of great questions that have come in. So first one, I think the question is for you, Bruno, I believe. Can we somehow use Sentry to instrument line numbers in stack traces? Unity makes it so stack traces simply contain bracketed zeros.
Yeah, right. So there's the Unity engine itself didn't have support for, or doesn't have support for, line numbers on IELTS-PP. So if you use IELTS-PP, which you have to publish to the App Store and Google Play Store, you don't get line numbers. So this is something that will change. So Unity is adding support not just on the client itself. So like you wouldn't get the line numbers if you do a debug.log, but with the help of server-side processing, it will be technically possible. It is not possible today in any LTS version of Unity, but Unity will add support to this in the future. And Sentry, obviously, it's a crash reporting tool, and that's what we do. We give line numbers to people, and it's definitely something we will add support as soon as it's technically feasible. Yeah, I think that's the answer.
Awesome. And next question might also be for you, Bruno. What are your plans for supporting the SDK moving forward?
Right. So our first iteration was with native crash reporting was Android and iOS, basically because there's just so many people targeting mobile. But of course, we're not stopping there. It was just the first thing we added. So Sentry has a very strong support for mobile, generally for iOS and Android. So it just fit really well when we got that Unity support combined with Android and iOS. But Sentry supports also native on Windows, on Mac, on Linux, and web. Obviously, it's probably the most known for web. So we're planning on adding still native support, which means like mini dump support for these platforms, for desktop, basically the standalone players. So this is something we want to do in very near term. So it should be coming out soon. And then console support is also coming. Yeah. So basically, it already should work with every platform except WebGL. You need to use the light version for now because it doesn't have thread support. But other than WebGL, the SDK works on any player, any sort of build that you make. But then the support of native crash support. So if you write code in C or C++, then it might not capture that still for some time until we add, say, on Mac and Linux and Windows.
Awesome. Yeah, I think you might have also.
Yeah.
Oh, go ahead. Sorry, didn't mean to interrupt.
No, I don't know if Stefan wants to add more because I just about native support, but there's a lot more we want to do in performance monitoring, etc. So maybe Stefan, you have thoughts.
I kind of spaced out.
Yeah, sorry. That's fair enough. Like we were just doing planning. So, if you're curious, the first thing that we'll tackle immediately is the Windows mini dump support. Like Stefan and I were just talking about this earlier. But yeah, basically all of them are coming.
Awesome. Yeah, you kind of answered another question that was also asked on what platforms do you now natively support? Did you add PS4 and PS5, which I think you kind of just chatted through. So yeah. 2 birds with 1 stone. Also, anything else you want to add before we move on to the next question?
No, I think that's it. So the performance monitoring is something that's a new product that Sentry has, and it's something that we showed a little quick demo that we use ourselves. But there will be a lot more effort into giving you value out of the box. But you can use that today already. There's a documentation, how you start the transaction and you finish, and how you create spans. And this will give you the timing information of, depending on the device you ran, and you get the idea of how fast your game is running in the wild.
Awesome. Thank you for that. That was great. Stefan, I think this next question might be for you. What can I get from Sentry without writing any code?
Yeah, so basically everything I showed in the demo is already available. Like you open up the config window, you paste your DSN in there, and all that capturing of errors, the native support for iOS and Android, that all works out of the box. The SDK hooks up into amongst other things into the Unity logger and fetches all those errors and captures them for you and sends them to Sentry for you to view in the dashboard.
Awesome, that's great. And then next question, I think it's also for you. With the large difference in device power, how do you strike a balance between making a game that looks good for everyone, but also runs well for most?
Yeah, that's always a tricky one. Like before,
yeah.
I mentioned the example for the AR mobile stuff. Like that probably depends most on where in the development process you are. If you're just starting out, there are a couple of decisions you can make to help ease the optimizing that you're gonna have to do by choosing maybe an art style that suits well for multi-platform. Other than that, if you maybe want to port, when your game is almost finished or maybe finished already, and you want to port it to a new platform that has some restrictions in place, Unity helps you with profiling. There are a couple of techniques you can use, from reducing overdraw by decreasing the amount of particle systems, and to ease up on the amount of effects that are going on, to reducing draw codes by merging textures, or maybe you even have to redraw textures, or you just shrink them down. The import settings Unity provides for those kind of things, where you can really target selected platforms to set those restrictions in place. Make it actually kind of easy and help you a lot.
Awesome. That's great. All right, just going down the line, these are really great questions from everyone. I think this is going to be for Joona, but if I'm wrong, I apologize. Is it possible to do the equivalent of uploading source maps in Unity to see the code detail in the stack trace?
Wouldn't be able to answer. Not in my domain.
Yeah, I think it's
Okay.
I think it's for me. So the support. So if you write the code in C#, you're not going to see the actual code inside Sentry. Sentry has a feature called stack trace linking, where on the line number, you can click on it and it will take you to your GitLab, GitHub, DFS, whatever you have as a source control, and then you can browse your code in there. It's something that we also want to look in Q1 to make sure this works with Unity. It's not a promise, by the way, that we're going to get it done in Q1. It's just something that we want to look at. It's a feature that Sentry offers in Python, Ruby, basically everything, and I don't think it's there for Unity yet. But seeing so uploading source maps is something that you will do the equivalent for Android, like there are ProGuard files, there are debug information files, like dwarf information file, that kind of stuff for native. So those we have, but not to read the code inside Sentry, if that makes sense. That for JavaScript you might have it, but you won't have it for C#.
Got it. Awesome. And then all the new features that we natively support, which are talked about here, are these available in the version 0.9.3 of the Sentry SDK?
Yes, that was the package that's installed in the demo. So everything you saw is 0.9.3.
Yeah. So the sample in this package includes a bunch of buttons, and the button might show up even though it's not relevant in that platform. For example, there's a button, throw Kotlin exception. So that is actually a .kt file, right? And it compiles on an Android game, and then it will throw a Kotlin exception. But of course, on iOS, it doesn't do anything because Unity is going to ignore the file on Android. But basically, there are C++, C, Kotlin, Objective-C, C#, basically. Lots of different samples you can try out there.
Awesome. That's great. Bruno, I think this question might be for you. So nowadays, games are increasingly server-side, not least because of the growth of cloud gaming. That in the last few years we will have, and that in a few years we will have many more gamers in this context. In what way can Sentry help in this context and make a difference?
Yeah, that's a great question. Like even on our Sentry defenses, so we have a backend. It's not a game server; it's just an API. But that API was instrumented with the Sentry SDK. It's a Google Cloud platform, like a serverless SDK written in C#. And Sentry is able to connect the request from the game into the server. And if there's an error on the server, it will be linked up it will be visible on the client as well. So you can see what erred on the server and how it had affected the client. So Sentry, one of the things Sentry is good at is basically supports all platforms. So if you have your backend in Python, Go, Ruby, Java, Kotlin, C#, anything basically supported, pretty much anything. Well, we don't have a COBOL SDK, I don't think, but other than that, it's with chances that we support it. So I think I hopefully answer your question, but I think in this way it helps you out.
Awesome, that's great. Stefan, I think this one's for you. Are there any manual steps that are involved in improving the information in the Sentry dashboard, like uploading debug symbols?
So that's actually something we just recently did. We automated away the need for you to do any manual steps. Inside the config window, like that's an additional step you have to take to get that automated. You provide Sentry CLI. That's an additional tool Sentry provides. That's part of the Unity package. You provide Sentry CLI with information about your Sentry project, and it hooks up into the creation process of that Gradle build and the Xcode project, and it uploads the debug symbols for you. There's some difference on Xcode. There's Bitcode where Apple does some optimizing for you, but even for that, Sentry provides instrumentation for Sentry to pull those files for you.
Yeah, so like I think this is nice. Thanks for touching on that. So I think Sentry is the only service out there, as far as I'm aware, that has this feature. So if you use Bitcode, Apple actually compiles your game, right? So you would have to download the symbols from Apple to then upload to your crash reporting tool. But Sentry has a service that connects directly to App Store Connect and pull the symbols out automatically. And the feature that actually Stefan just built is that uploading the BC maps, like the Bitcode map files, is also automatically just part of the build. So if you build an iOS game or an Android game, your ProGuard or like native symbols SO files or DSYMs, all that stuff just gets sent to Sentry automatically, and you don't have to set up Sentry CLI manually and download things and configure command line arguments or any of that anymore. So that's pretty neat.
Awesome, that is great. Well, Bruno, I think next one's for you anyways. Is there a roadmap plan for WebGL support?
Yes, we have a draft PR on this. We've identified what the problem is. Basically, Sentry's SDKs send events to Sentry on a background thread. That is to avoid running things on the event loop, right, and slowing down your app. The problem with doing that on WebGL is that the Unity, at least implementation WebGL, does not support threads. So even if we just use the HTTP client from .NET, which compiles and works there, the cancellation token relies on a timer, and that doesn't compile or doesn't run. It actually fails at runtime. So we know what we're missing. We will just have to re-implement a new HTTP transport that will be based on the Unity HTTP class, and that's all we need. So basically, we want to do this really soon. Yeah, it's coming.
Thank you for sharing. I think another one for you, Bruno. You're pretty popular. Telemetry is increasingly essential for detecting errors in real time, but it's also used by some companies to detect irregularities in data, which are often altered using external software such as cheats. Does the Sentry roadmap have something related to security as well, tampered files, bypass attempts, things like that, etc.?
Mm-hmm. Yeah, it's a good question. A few things you could be able to use, like you would be able to do yourself today with Sentry, but using the SDK. So the SDK has a lot of APIs that allow you to use Sentry. So like a lot of what Stefan showed you today is we use the SDK's API to create that. Like we call Sentry SDK.add breadcrumb, and we hook that into the sing loading from Unity, right? And then you show the breadcrumb there. So if you know what files you want to monitor, for example, if you have a hash of a file somewhere and you want to compare against the hash that you downloaded from the internet, you could do this yourself. And if the hashes don't match, you could call Sentry.capture message, level error, and the hash of this file didn't match the hash of that file, et cetera, et cetera. And you would get alerted of like you wrote the error, like the security detection yourself, and you use the API to communicate with yourself. So that said, it's not that we don't want to add, or we haven't had any plans to add something like this out of the box, but if you have ideas on like specific use cases that we could cover and the SDK could add out of the box, like we're happy to consider this. So we developed this SDK on GitHub. You can raise an issue there with us. I will link, I'll put a comment on the chat here. And so you can just raise an issue and then propose a feature, and we're happy to discuss there.
Awesome. Are there limits on data that can be sent? Will logs be capped or cost effective?
Sorry, can you repeat that? How many logs can you capture? Sorry.
Are there limits on data that can be sent? Will logs be capped or cost effective?
Oh, right, logs will be capped. So each event is has a limit of about 100 kilobytes in payload. So you could, like with the SDK by default, cap the breadcrumb list to 100 items, but you can change that. There's a property and you can change to 200 or whatever. But if the whole payload, the whole event goes beyond, I think it's 100K. It might be more these days. It's probably on our docs, so I would check there. Then the event will be rejected, and you would see some stats saying that event was too large and was rejected. So this is one sort of limitation. But the field itself, if you send a pretty long breadcrumb, we're not going to truncate that. The Unity SDK doesn't truncate that. That's not always true for all SDKs. It depends on the SDK. So there are no really logic of truncating different pieces inside the payload. But there's a general limit on the overall payload. So if you send like a 10 megabyte event, it's going to be dropped by Sentry at the entrance. That said, there are attachments. Attachments can be pretty large, multiple megabytes. So you can get a random, like a file, like a log file, a video, an image, and you can attach and you can send it to Sentry together with the event. So, yeah.
Thank you. Almost there. We got a couple more questions, so thank you all for hanging on. Stefan, I think this might be for you. For Windows mono builds, should I be able to get line numbers without doing a development build?
Yes, you should.
Quick. And then I think this is the last question that I see so far, so we might be able to end a little early. The automated upload of symbols happens during builds of iOS and Android players. Is that correct? What's the difference between the upload symbols under the editor tab in Sentry settings? So this might be for either Stefan or Bruno.
Yeah. So that's the part I mentioned before, that upload symbols. There are 3 text fields, and the config window requires those to be filled, so it knows where to send those debug symbols to. So it happens automatically once you configure it. Like you have to provide an auth token so that you verify that you have access to do that. It needs the organization name, and it needs the project's name, so you can associate those files with the correct project.
And it's like, just to add why it works this way, the Sentry CLI settings, so the settings used to upload symbols, is not data that you want to make public. So there's an auth token there. So this will go into a file called Sentry CLI options, and you want to put this on on git ignore or whatever, ignore on your version control system. So we mentioned that on the docs, right? And the DSN, it's a public information that routes events. It does not allow people to upload debug files to your project, only to send events. So this goes into your game in the end and goes to the store and gets downloaded to a customer's device, right? But not the Sentry CLI options that Stefan mentioned, the auth token, org, slug, and project name.
Awesome. I think those are all of the questions. Is there anyone else, Joona, Stefan, or Bruno, or Rahul, that you'd want to add? Otherwise, I think we can close out.
Yeah, I'll go. Input from you really helps us build the SDK. A lot of the things, how we prioritize them, came because of feedback from folks. You can either raise an issue or see the issue you have on GitHub and give a thumbs up if it's something you want, like, oh, I really want this feature. We're also on Discord. There's a badge on our repo to get to the Discord server. And there we can chat and you can give feedback. If you have any problems with the SDK, we would like to know about this. If you like it, if you don't, we're also happy to hear any sort of feedback about it.
Definitely. And I'll add for the workshop as well. Like I said, survey will pop up at the end. We thrive off of the feedback that you guys shared with us. So without further ado, I do want to thank our speakers, our panel, as well as everyone who came and attended and listened and asked really, really great questions today. Please send us the feedback, whether on the SDK itself or the workshop or both. So I will let everyone go with a few minutes left to spare, but really thank everyone for your time, and we will be sharing the recording out as well, just as a reminder in case you want to relook or have someone who can attend. So thank you so much, everyone. We will see you all soon.
Thank you.
Thank you. See ya.